Section 3. Generics, operators, and other building blocks. In this section, we're going to learn how to use dictionaries in Swift, what generics are and how to use them, how to use operator overloading and how to introduce custom operators, how to return multiple values from a function and how to pass another function into a function as a function parameter, and last but not least, how to write cleaner code by using type aliases. Before we get started, I just want to mention that for the whole section we're going to use Xcode Playgrounds. It's a great and simple way to test some code without having to implement a full app. There is also an iPad app available from Apple called Swift Playgrounds that's very nice to check out as well. Dictionaries and how they work. Dictionaries in Swift are often called hash maps in other programming languages. They are basically a storage in form of a key and a value. Access to such elements in a dictionary is very, very fast, and that's why they are used a lot. But I would say, let's get started. Now let's open up Xcode and we will be greeted with this welcome screen. Just click Get Started with a Playground to get started. You are greeted with this wizard where we're just going to choose a blank playground. Just store it somewhere and call it Dictionaries. Now this is basically how a playground looks. You can start coding right away in this file and you can always run the contents of this file. So it's extremely simple. Let's start by exploring the syntax of a dictionary though. As I said, it's a key-value pair. So this cities dictionary has a key that's of type string and a value that's of type string. Now we're going to use that to use the key as the actual city and the value as the country where this city is located in. Now, as you can see here, London acts as the key and United Kingdom acts as the corresponding value. A key-value pair is simply written with a colon and not with a comma. Comma is separating each individual entry. Now, it's also possible that the value is not just a single type, but an array. For example, like this. The key is now a string, and the corresponding value is an array of strings. Let me copy over an example. Now here are some contexts where the corresponding key always has a list or an array of names that start with this letter. For example, A, we have Alfred, Anton, and Arthur. Let's print those contexts. Now the nice thing here in the playground is you can simply write print statements, open up this bottom drawer and hit run. Now here the dictionary gets printed. We can see that the corresponding key A has as a value an array with 3 names in it. Now let's see what else we can do with this dictionary. For one, we can iterate over it. Now let's run this again. We're in this for loop iterating over every key in contexts, and for every key in the for loop we get the corresponding values, the names as well. That's why we are able to print the letter and the names in this print statement. We can see the result here below. Now let's see how we can access individual values by using the corresponding key. Just like with an array, you use a subscript of the corresponding key to get the values. Let's print contexts with A to see what the result is. Let's run the playground. And here we can see contexts with A, optional, Alfred, Anton, and Arthur. Now why is it optional? Because the subscript accessed with a key might not have a value in it. So let's try something different. For example, if we access our contacts dictionary with the key B, we do not have any values stored with it, so the result will be nil. Let's run that and confirm. Contacts with B is nil. That's why Swift just returns an optional type of the values, in this case a string array. Now, if we want to make sure that we are always accessing the value instead of potentially an optional, an if-let statement comes in handy here. Now in this case, let's run and confirm. You will also get rid of this optional because that's always added by Swift automatically whenever you print a optional type. Now let's see what else we can do with our dictionary. It's very easy to convert the dictionary back into an array as well, or at least the keys or the values. For example, you could get all the letters of the dictionary by saying letters equals contacts.keys. Printing the letters will give you LDSA. Now, you also might have already seen that the order of the dictionary and the order something is printed in is always completely random. A dictionary does not guarantee any kind of sorting, so that's always very important to keep in mind. Similarly to getting the keys, you can also get the values. In this case, this would print Lee, Leonard, Dennis, Samuel, Cynthia, Alfred, Anthony, and Arthur. Now, you can also store custom types as values in dictionaries, as you might have imagined. Let's use, instead of a contact that's simply a string, let's use a custom struct. It's simply a struct called contact that has an ID, a name, a phone, and an email. My contact dictionary could look something like that. For all the contacts starting with the letter A, we have a contact object attached to it, or an array of contact objects to be precise. Printing this gives the following result. It prints every contact with its name, the phone and the email is in this case always nil, and also with the ID. Now, but what if I wanted to use my custom class as the key instead of the value? Well, that's no problem as long as the custom class conforms to the hashable protocol. Let me copy over an example and explain. Now in this case, I'm copying over a struct called product that conforms to the hashable protocol. It contains a name and a price. What is very handy with structs, you don't only get the initializer for free, but in this case also the hashable implementation, because every single property of product is also hashable itself. And then we have a struct order that has a products dictionary. For every product as key, we store an integer that represents the amount or the quantity of the product that was ordered. Now let me copy over an example of an order. We are creating a new order of products and we're buying a water for 0.49, 10 quantities, and rice for 1.29, 1 quantity. Let's run the playground and see the result. The result is in the last column where it says product name rice, price 1.29, 1 amount, and water 10 amounts. So that's how you use a custom class or a struct as the key of your dictionary. This was the video about dictionaries and how they work.